Yeah, I know that the title is sort of buzzwordy. It was either this or idiots building telephone system. So, yeah, you think I'm kidding. But well, hello. My name is Kim Rosgaard Christensen. It's Danish and means brilliant engineer. Don't check it. Just take my word for it. Danes don't no don't know. This is a story about how we use Dart, how we came to use Dart in the building of a soft real-time system with a browser UI. I'm trying to cover some of the more, well, at least in my opinion, interesting aspects of this. So the talk focuses mainly on the server side aspects of Dart and some of the development methods that we've used. This is my best effort to try to summarize roughly 5 years of development into 25 minutes, so I hope things don't get too fragmented. Why should you watch this talk? The nice people at Google asked me this, so I'm including it. At first, I answered this without hesitation. I have no idea. Because I didn't felt this was a big thing. But it got me thinking, why? So it's basically an example that Dart is not a web-only language. It's actually stable enough to base availability critical businesses on it. Okay. And we've used it for a variety of things, which I'm going to cover. And also, it's a story about Dart in the wild, which is also, it's always fun. It's always fun for developers to hear stories about how you solved this and you used language X, something like that. But first, a bit about the problem, the project, sorry. The project, which is actually the turning point of this talk, started roughly 5 years ago with the purpose of replacing an existing legacy system for a company that hosts external receptions. Now, this is the best description, and it's sort of abstract, I know. So, the following slides are meant to take you through the business model in order to hopefully unconfuse you a bit. Because the business model is not complicated, but it's hard to communicate. I'm going to try to give an example. This is Mark, you know. So due to licensing issues, this is Mark. It's a me, Mark. Mark is a hard worker. He does not mind getting his hands or head, it would seem, very dirty. But as he is doing his work, this happens. So, now what? This is a very important customer dialing now. Luckily, Mark has a reception hosting service at Reception Hosting Inc. And what do? They pick up his phone and they send it to Lars. If he's available. If he's not available, they could just take a message. So this is basically what they do. And Reception Hosting Inc.'s business model is that they do this for many different companies, which all of them have their heads in tubes. But they need some software to actually realize this business model. And who does that? Okay, so yeah. Spoiler alert. Backing up or fast forwarding, depending on the view, I'm going to give a brief overview of the system architectures. This is the old system architecture, which consisted mostly of broken love, tears, and trash. It's also horribly interconnected, which included a Windows XP only client. This is actually the serious part of it. It had unfixed critical bugs. You had to restart it every week, and all these things. So we really wanted to make things right this time around. This is supposed to, is that orange? It's orange here. I'm horribly colorblind, so you may need to scratch your eyes out for the rest of the diagrams. The components here, which are sort of orangey, are the ones that we've written in Dart. This is a high-level view of the components of the system. Receptionist over here should be viewed as a receptionist desk. Every receptionist has a web client and a SIP phone. Notice there are no communication between these two. Every synchronization needs to happen here. So updates to the web client are sent from here, actually through a notification service, but that doesn't really matter, to the web client. The basis of it is a software PBX. For those of you who do not know what a PBX is, it stands for Private Branch Exchange, which says nothing about what the hell it is. I don't know why it's called that. But it's a piece of software that handles phone calls, in queues, people, and things like that. So every time you're annoyed in a phone queue, you're hanging in a PBX. This is event-driven. So events will emit from this software PBX onto the call flow service, which will then translate it, put it into the web client, make logic decisions based on it, detect phone state, stuff like that. Every time a receptionist wants to pick up a call, they need to proxy it through this call flow control service, and the call flow control service will then send it to the SIP phone. All right, basic overview. Yes, live demo. Let's see. Where did I put it? Okay, so this is the user interface. It's generated mock data. I've used my test environment to auto-generate and start this. So it's Danish mock data, sorry. I've also, I'll be with you in a minute. I've also coded up for this event a small automation script which should actually place a phone call, put it into the queue, which is over here. Can everybody see? Should I zoom this? It's okay? Good. Okay. Should put it into the queue, wait for 5 seconds, then being picked up, placed into my calls, wait 5 more seconds, and then being answered. It's just widgets, you know? So you have this, well, this greeting, you have some reception, filter, selection, some commands. What are you going to do when you get a call? You can take a message. You have some contact, so you can call Lars or anyone else. So I'm going to press enter now and hope for the best. Yay! Oh. So phone call is ringing. This is an actual phone call in the system. It'll be answered, wait 5 seconds, and then be hung up again. This was the easiest example I could get working without stuff breaking. I hope it gives you this is the receptionist view. So I hope this gives you a basic overview of how they work. And then I need to go back to the slides, which is located there. Yeah, okay, so this is for fallback. I didn't need it. Okay, so why Dart? Did you always start out with Dart? As I was saying at the beginning, we were idiots building telephony systems. I think that's sort of an overstatement. I would describe it better as monkeys with big ambitions. We knew absolutely nothing about telephony or a lot of these things before we started this. So we had big ambitions. So obviously we started out programming this in Ada. JavaScript, Ada, Python. That was our stack. JavaScript for client, Python for tests, Ada for server. So yeah. Ada is a very nice language. I'm not going to trash talk it because I really like it. The problem wasn't really with Ada. I think the problem was mainly with the tooling around Ada because you couldn't iterate as fast as you can with Dart. For those of you who do not know it, it's type-safe. It's used, for instance, in aerospace and railway industries. So you can see why we thought that we should use this for our little system. Well, we started using Dart pretty early, late 2012 for the client. So we could, and already at that point, we could see some of the benefits from using it on the server side. So we started looking towards the server side and migrated to use it in our microservices around late 2013. Around 2014, our entire stack was running Dart, and one of our developers quit. There's a fun fact. So back when we were using Ada, people were saying, "You're using what? What? Why? Why are you using that? It's a dead language." So that hasn't changed. What are the benefits of Dart? Well, this pretty much sums it up. The best benefit. You can share things, you can share models, and you can share interfaces. We've written up some clients which are transport agnostic. So like I think there was at the development thingy Tuesday, there was this guy who talked about vTransport, which was this Dart.io, Dart HTTP independent client. Yeah, this was what we did ad hoc. But it means that you can just instantiate the same client depending, no matter if you're here or here, and this opens up a vast amount of possibilities. One of them, and remember, this is maybe 2013, 14. One of it was integration testing. Because we had in our stack, we had the PBX, which was, it's open source, but we didn't really want to look that much into it, so we treated it as a black box. And we had our phones, which are hardware phones, which was a big wildcard in our stack. So we had to treat those as black boxes. So for our integration tests, we thought, okay, so why don't we treat our entire system as a black box and just run tests against the system, which we did. And this meant that we programmed what I called a test environment, which could then, if you were a test, you could say, I'm a test. I would like to test this functionality, and for this functionality, I require a set of services. The test environment would then spawn the processes for you, and then return the interfaces needed and the clients. And then upon test termination, they would tear down the processes again, and you could start a new test with a clean set of processes. And one of the big benefits of doing this is that you get on test output the same, you get all the output from the services. So it's a big distributed system where you can actually capture output of every service involved in the test. So now imagine that you're using continuous integration and you have a test failing. You don't know what, you don't know why, but you have this big log. That's log data, that's not like tree. And you don't even need to replicate your test. Maybe you can't even. Very useful. Okay, that aside, we added another thing which is called use case tests, which is much more high-level testing. where you have the same pattern just with actors. So this is an actor model. It's not the actor model. Something I made up because I'm clever. No, I'm not. I'm just an idiot building a telephone system. Okay. What we did was mapped different actors to classes and then mapped their capabilities. So this is UML capabilities. You need to think UML use case into their methods, into different methods, and then realize the capabilities from interfaces and models. Okay, so what would this look like? It would look sort of like this. So this capability for a receptionist user is send a message. You get this should be have been uppercase. Never mind. This is a type from the framework, and this is a client from the framework. All type safe, and it's a realized capability. So using this, it looks like this. Test environment, request receptionist, blah, blah, blah. We make a mock message, we send it, and we can do some expectations. Very high level, very nice. Actually, let's see, okay, yeah, I have much time, that's nice. Actually, this one here, so you remember the user interface I showed you? The call coming in? This was the piece of code that was being executed. That's pretty nice, huh? And this actually opens up a whole new world because, I know it's cumbersome and it's tricky to do, and you have to write a lot of code in your test environment, but it gives you the benefit of developer documentation, right? So developer, you can communicate this to a developer. How do I realize this? Oh, I can see, okay, so when a receptionist needs to hang up, I can just, let's see. This is hard to do. You can go with this. Okay, so it needs to, yes, I know it's a this keyword. Okay, so this is a call flow control service, and it's this one. Oh, I can go on. So you can actually see the entire chain of calls, like language calls being made, which is good, in my opinion. Okay, back. Sloppy focus, sorry. Yeah, there's a lot of code overhead in this, I know. But it actually enabled us to change our Ada code into Dart code almost without feature regressions. So this is nice. It also enabled us to test a lot of things at once, treat our entire system as a black box because we had many distributed components. So this is a good, at least in my opinion, a very good strategy for testing this. It cannot stand alone. We still have unit tests and things like that, but okay. Deployment. We called this the day of doom. You can imagine. But before, we did some simulations. Using the test framework, we could create a lot of, like you saw in the code, a lot of customer objects, which we could then script into making lots of phone calls into our system. Then put a receptionist agent robot, which is just a Dart simulation file, which is situated in the UI, and it keeps track of the call list by just checking for list elements. Whenever it detects one, it will try to pick it up and go through a state machine. So randomly say, okay, I'm going to perform this action on it. Everything is salted with a random latency, so we don't get live logs. And we started up, I think, 15 agents, and then start hammering the system. It took about, I think we handled maybe 200,000 calls over a weekend. And no crashes. Yes, the migration. We migrated 900 PS10 numbers, which doesn't sound like a lot, but remember, in Denmark we only have 8 digits of phone numbers, so it's actually like a big percentage. But it's about 600 or 700 businesses, which would, if we failed at this, be without telephony service. So we did this in 2 critical phases. We started Friday after hours. We diverted all the calls to the new system. So that was 0 downtime. Now we were on the new system and everything worked. We had no human interaction in the system. Everything was handled by the PBX because we compile all the dial plans statically. Dial plans are just instructions for what to do with the call. Monday morning at 8 o'clock, the receptionist came in and started using the system. We had never had non-technical people using this system before. So they started hammering on this, and we had a fire extinguisher, we had speed dial for the telephony providers, so we said, okay, we're going to roll back. But as it turns out, there were no bugs in this. Everything just worked from the moment of deployment. How about that? I think that's amazing. Come on. All right. So, in this application, we have about 100,000 lines of code. Almost all in strong mode. The tests still have some work needed. The system has handled about 700,000 or 800,000 phone calls since February, I think. We've not experienced a single crash caused by Dart. Yes, we're not good at creating database schemas. Well, Dart has, for us, been a more than adequate tool and provided us with sufficient type safety and testing tools, and we still maintained a rapid development pace. So, in summary, would be that Dart actually empowers monkeys with ambition to build phone systems. But I think we should market it a little bit differently. Thank you for your attention. Oh, there's still time.
You can just make up more slides.
Yeah, you're not off the hook yet. Yes. If you want to check this out, we actually have it on GitHub. The README is work in progress. Pull requests welcome. If what?
No, I wasn't going to say no. You're good. Keep going.
Yes.
So is this available as a package, or is it just an app?
It's a full repository. It's like
I know, but do you have a package that you publish, or is it like it's a self-contained app?
It's a self-contained app that contains a few different Dart projects, like 4 or 5 different Dart projects in one. We merged them all because we could have some benefits of the static analysis of the Dart analyzer.
Like, we have time for maybe 1 or 2 questions for Kim?
I think Philip's going to start switching out hardware.
Oh yeah, we need it. Yeah. Okay.
Can I? Okay. Let's see. Yeah. Okay, that's fine. Just go ahead. Yeah. Questions?
You able to keep up with Dart SDK bumps, and did you have to do a lot of testing?
Let me repeat the question. The question was, how do you handle SDK upgrades and roles? Do you keep up with the latest SDK? How do you test?
We test with Jenkins. So yeah, that's the short answer. Of course, the long answer is that we have a Thomas, which is he's an early adopter. And he just pulls down every new package he can, and he figures out okay, so there's a breakage here, and he sends a bug report to me. I don't know if I mentioned it, but the last year and a half, I was almost alone on the project, along with Thomas, which took care of the UI. So most, if not all, of the testing, the server stack, the socket communication, all the things is done by me. So it's actually one monkey.
And you'll stick around, so if you have more questions, we can talk to you afterwards.
Yeah.
Fabulous.
Yeah.
What about implementing a soft phone in the web client too?
Yes.
The question was, what about implementing a soft phone in the browser with WebRTC?
Yes. It's in the pipeline. That's the short answer. We did some experiments in the early days with using a library called PJZip, which is an open source zip library. But we had troubles getting it to work with ALSA, things like that. So we took a quick decision and took the client phone or the receptionist phone out of the equation and just bought hardware phones. But yeah, we would really like WebRTC. So it's an all-browser app because it also eliminates a lot of firewall issues, at least moves them. Did that answer? Yeah.
Cool. Thank you so much for your time. Thanks, Kim.